All right, guys, in the previous video, we were machining this block right here, and I discovered that I was running the wrong size tap. We ran a 1032 tap when I had found out that, in fact, that we're supposed to be running an M5 tap for these screws here. So I didn't have the tap that I needed, so I placed an order and got them in the next day. I've already got the M5 tap installed. I took the tap drill out that we were using, which was the number 21. I installed a 4.2 millimeter drill for our tap size hole there. And I've run this a couple of times doing some testing. This one turned out great, so I wanted to run it again right here. I've been adjusting my wear compensation on the cutter to get the slot size where I want. And it's there, and this is technically really good, but it is 1/1000 over what I would like it to finish at. There's nothing wrong with the width of this slot, just the way it is, but I made another adjustment to the comp, brought it down just a little bit. And I'm just showing you that the screws go in there just like they're supposed to now. And so what I would like to do is I'm just going to flip this block over. We're going to run it one more time now that I've got another adjustment on my wear comp. My goal is to machine this slot to 0.501. I finished this one at 0.502. So I made an adjustment on our comp. We're going to see if we finish it there, and hopefully it will be. And after this, if everything's good, we should be able to move right over here to our Toolex vise and go ahead and get these soft jaws machined. And those Mitee-Bites sure do grab that thing tight. Talon grips, that's what those are. All right, so we're just going to flip this over. You can see this old rusty piece of flat bar. We're just using it to make chips and test our programs with. I'm just going to eyeball it's just about the same width of our jaws there. And tighten this thing up. All right, now I will need to reprobe it just to find the top of it right here. So I'll do that and we'll get to cutting. And I'm gonna try a new camera angle this time. We're gonna put you inside the machine. My hopes is that you can get a good clear video of the machining. Got the camera mounted inside the machine this time. So hopefully that's gonna be a little bit better shot. That of course will change depending on the coolant. But I don't think it's gonna sling too much. So let's get rolling on this. I'm going to start it off slow just to make sure that I am probed correctly here. That's looking good. All right, let me turn everything back up. Here we go. So it's going to make a pass down each side to get it to our 1/2 inch width. And I had modified it, hopefully correctly, so that it will repeat. Yep. Basically just making a spring pass there. It has constantly surprised me on how well just doing a repeat pass will clean something up. You know, it'll easily take a 1/2 thou out of a bore or a slot size. So now it's cleaning up the other side of the slot. And it'll repeat that. Hopefully you guys are getting a nice clear video out of this. mill drill. It's going to chamfer the top corners. So it'll chamfer both edges, and then it's going to spot all of the hole locations as well. 1/4 inch diameter mill drill tool. Next up is our drill, 4.2 millimeter. I modified the drilling cycle as well. What I did was, I've got a 30 thousandths peck depth, and I got an accumulated peck depth of 350 thou. That's so it'll only clear that hole one time. That seems to help speed it up a little bit when you don't have to come up and out of the hole every time. But changing the peck depth has also greatly improved the chip packing that I had wrapping around the cutter there. It seems to break the chip off nicely and just get it out of the way. So 30 thousandths peck depth, and I changed it from the default 4 thousandths peck clearance to 8 thousandths, and it all seems to be working well now. I wanted to mention that so far, the limited time that I've been on the new VM, I'm really pleased actually with how well it's running. It's nice and smooth, and it's super quiet too. Standing outside the machine here, it's just that spindle is super quiet. Now, if you're hearing what sounds like a thump, like a banging noise sort of in the background of the audio here, that is the welding shop next door. And it sounds like they're over there with a sledgehammer beating on the side of a dumpster or something, which is a really common sound. They do a lot of repairs over there. So if you're hearing some kind of thumping sound, that's what it is. It's next door. It's not the machine. All right, I believe we're on our last hole there. By the way, that coolant nozzle all the way to the right side, I have that positioned for the tap. That's why it's not coming out on the tool. Going back with our mill drill, and this is going to chamfer all of those holes now. So I do get a lot of comments about, why don't you just chamfer it, like this tool right here, why don't you go down deep enough so that it cuts the chamfer without having to come back? The quick answer to that is because I don't want to risk breaking that tool. I've only got a couple of those. I've already broke one before. By doing that, I don't mind coming back after the hole is drilled and just chamfering the hole at that point. I understand if it was a production, you want to speed it up, that's a totally different scenario. Going in with our M5 tap and our wonderful microfloat tap holder. And it worked before, so hopefully it's going to work again. Now you can see that coolant to the right side. I've got it blowing right on that tap. And then I leave the other two alone so that it hits the cutters for the other operations. I'm running this tap at 500 RPM, by the way, just in case you're wondering. I haven't figured out what the optimal speeds are for our power tapping. I just haven't done it enough, so I try to keep it moderately low. Again, if we were in a production environment, we would be trying to optimize it to run as fast as it possibly can. But we're just making a couple parts here, so not a big deal. But I'm miles ahead versus doing that in the manual mill, I'll tell you that. All right, that's into the program. And that took us 13 minutes and 21 seconds to machine that slot there. Everything's looking good. We do have a few chips around the tap here. They weren't packed on there though. It looks like the camera's doing well. I don't have any coolant on the screen. Hopefully it looks nice and clear. Thought I would show you the mount that I'm using right now. We've got a suction cup there with a ball swivel mount, so I can mount it where I want. This is the feature that I really like about the newest GoPro, the 13, is that it's just got the little magnet clip there, and it just snaps on. And I got an extra mic here, so we'll see if this continues to work well. I need to get a couple extra though, so I can get these mounted in the machine. And then I've got my this light right here. I got that just stuck right there to the inside of the door to kind of shine some light that way. So this might be working. I'm going to add another clip light up there, and we've got that clip light right there that's kind of helped brighten it up. So let's check our Talon grip. I have not measured it yet. Thought I would just do the check by hand and see how it fits first. That is what I wanted right there. I mean, you just have ever so slightly amount of interference there. That's probably just the coolant that's making it stick. I was trying to stick there, but yeah, that's good. Just enough clearance that it can go in there. You don't have to fight getting it out of here whenever you want to move these things. That's the goal there. So that worked out well. Our wear compensation, I've got it set at negative 0.5 thousandths. And with the combination of that repeat finish pass, it's landing us exactly where we want it at 0.501. We are on it right there. Let's put one down here. You can see how it's trying to stick up just a little bit. But you have complete free movement in there. There we have it. Awesome. Really happy with that. The machine is doing great. All the cutters are doing great. It's doing exactly what I'm telling it to do. Nothing more, nothing less. All right, let's get these guys out of here. I think that's going to be enough for our test cuts there. All right, I'm real happy with the results of our test block right there. And I'm going to go ahead and spend a little time and make sure that I have our program for the vise matching the slot that we machined over here. I've been editing this guy, and I've been transferring those same edits to our actual program for this. But I want to double check it and make sure everything is the same, and make sure that we're ready to go. Make sure our work offset is correct for the program, and that we're probed correctly here, and then we'll be ready to machine. So keep in mind, we're going to duplicate this 4 times. We'll have 4 total of these slots in there to machine. And you know, this one was right at 13.5 minutes, so we're going to have close to an hour machining this. And you know, one of the reasons it's taking so long is because of the drill cycle in there, but I'm using a high-speed steel jobber drill. But it's perfect for stuff like this. You know, if I was going to be doing a lot of these things, I'd go ahead and invest and purchase a carbide drill, 4.2 millimeter carbide drill, probably coolant through, because you would be able to blow them holes in there in just a matter of seconds and be done with it. But one part that we're machining, I've got jobber drills here. They're on size and they're getting the job done, and it's doing a really good job too. So anyway, when I bring you guys back, hopefully we're going to be working on this and getting this guy machined. All right, guys, I wanted to go over the Fusion program and show you what this actually looks like, you know, before we go to the machine and start doing the cutting here. So we are in the design aspect, and I want to give a shout out to the fellows up there at Tico Manufacturing. They helped me with this program here. They provided the solid models and the jaws that we're going to be machining. The design that, like you see it here, they provided that to me, which allowed us to more easily create this program to do the machining. So this was another really great training session with Kevin and him, again, teaching me how you can use solid models in your design aspect, like like this guy here. And he taught me a few other features, which I'm still very green at, on how to lock all these pieces together so that they don't move and things like that. But I'll just do a quick rotate around the Toolex vise here. This is the vise that we have, the Relock by Toolex. Really cool that how the solid models work with this CAD software. And all the dimensions that we need are already built into this. And again, that was provided by the guys at Tico. So big thanks to them for helping me with this. And so we just had a little bit of work here to do in the design, and got all that locked together the way we need. And I had mentioned earlier that we have this, the gaps in the jaws right here are, in our design, are 3/8. If we do an inspection, and we can go from this point to this point, 375. Okay, so we've got our 3/8 shim blocks in between the jaws, and we've got it tight. So that is good to go right there. All right, so we're going to jump over here to the manufacturer side of it, and this simulation is going to be a little slow and jumpy, so I'll try to jump through there kind of a little quicker. I think that's just my computer, just the way it's been operating here. But if we go ahead and go to our simulation and get this started, what we're going to start with is exactly, well, you've basically seen it in the test block. All right, so we'll go ahead and get this going. You'll see what I mean by it being kind of jumpy there. So the first pass is a 2D contour, but it goes right down the middle of the slot using a 3/8 end mill. And that's just busting out the width of the slot in 3/8. And once it machines all four, you can see right here, this is our fixed jaw, you know, and our two outer jaws, and these four slots are what we're going to be machining. These two areas here represent the opposite side. When you rotate at 180, we're going to be machining these on the other pair of jaws. So never mind these two outer blue areas, but that is stock that we will be machining. So once it does that 2D contour, it's going to come in for a finish pass using a 2D contour again. And the way that I've got this set up, and it's working really well, and putting this right on size with our wear compensation adjusted, is that it's going to repeat that pass, repeat finish pass. That's what it did right there. Now it's coming down and cleaning up this inner sidewall right here. It's a little slow to react, and I hate that for the video here. But we're going to come down and finish, repeat finish pass. Then it'll move down, and it's going to clean up this slot. All right, so we'll go ahead and fast forward to the next segment here. That's the next slot. And this slot right here, number 4. And once we get those, we'll come back in there with our chamfering tool. It's going to chamfer all those edges there, all 8 of the edges. Fast forward that. And then it's going to chamfer the 4 outer edges, the lower edge there. You come over here, let's see. Can we pause that? Let me see. This is something that's really cool that I think. Let's see if we can bring you in with my mouse like this. And so what I like to do, let me see if I can rotate this guy around where you can see it a little bit better. It's pretty cool, you know. You can zoom in here, way in here on this part. And we're just going to control this with our mouse. It's going to come down to this bottom edge right there. You can see it's going to chamfer just about every bit of that. And we have this set, so it's not going to crash if you get the right camera angle here. Rotate around. There's the gap right there. So the way that we have this set up is that there should be a 1/1000th gap between the shank of the cutter and that sidewall right there. And I've done this before with a few other jobs, and it works. Makes me nervous, but you know, once you've proven it, you know it's going to work. It works. So anyway, it's going to chamfer all 4 of those lower edges there. All right, that same tool is going to come back and spot them. And again, I know that you could use this tool to cut do the spot drill and the chamfer all in one setup, but I'm afraid it's going to break the tip off. I don't have enough experience with using a spotting drill to drill down deep enough for the chamfer to be built into it as well. So I'm going to come back and just chamfer every one of those holes after they're drilled. All right, so now it's moving on to the tap size, which is our 4.2 millimeter. And that's working really well. We'll go ahead and fast forward that. Now this is where we come back with that same mill drill, and we're gonna chamfer all those tools. It's just a straight plunge move to get it to the right diameter. And then our last operation is gonna be our tapping there, our M5 tap. All right, and then there's the end of the program. Fusion's telling me a little over 40 minutes. I think it's probably gonna take a little bit longer than that to get this done, but that's okay. We've got one pair of jaws to machine, so this is what I'm focusing on right now. And once we get this machined right here, this vise will be finished up, and then I'm gonna focus on the right-hand vise, which will have these features milled in there for the soft jaw or for the op-2 operation. But we're gonna focus on that once I have this one completed. So we'll go ahead and get started on this guy now. All right, guys, we're gonna get started on this. I did make an air cut off camera. Everything looked like it was gonna be right where it needs to be. So I'm gonna do my traditional, I'm gonna bring it down slow just when we start to be sure that we have adequate clearance. You know, I've got our extensions off of here about 200 thousandths, but just to make sure that it doesn't hit coming down on the plunge move. And if that's good, all the tools should be good. But once we go to our chamfer tool, I'll probably bring it down nice and slow just to confirm that it's there. And then once I confirm that, we're gonna send it at 100%. And by the way, I'm gonna break this program up into 2 cycles, okay? We're gonna machine the 4 slots first, and then I'm gonna check those and make sure they're on size. And then if those are good, then we're gonna go on to the hole making after that. Turn that coolant off. Let this cutter get down to where it's gonna start. I think that's good. I got my feed down to 0, so let's come up slowly with it. See how close it is to that end mill? It's with a 200 thousandths extension on that. All right, we're gonna roll with it. Let me turn the coolant on. And here we go. All right, there's 100% on our feed. I have to just try to relax and let the cutter do what it's supposed to do. It sounds good so far. Keep in mind that's 4140 that we are machining there. Okay, this is going to be the first of our cleanup cut, bringing it to our 1/2 inch width. Our repeat pass. Down the opposite side of the jaw. All right, everything's looking good. Well, so far that is working great. Just about through widening out our slots, and then we're about to swap over to our chamfering tool. All right, again, let me just double check this. Okay, that's looking pretty good. Bring our rapid up and then bring our feed rate up slowly. Yep, okay, here we go. Let's send it. I don't really think we need coolant on that, but all it does is help the cutter and help the finish when we use it. So we're just gonna roll with it. This is where I'm going to slow it down. We're going to go ahead and turn that coolant off so I can watch this. As soon as we get to that edge, I'm going to slow this feed rate way down. Right there. I got a rapid turn down. It's going to come down on that bottom edge, and hopefully it's going to clear. That is amazing. I'm gonna go 50% on that. That is it. The slots are finished with the exception of the holes. All right, that took us 12 minutes and 36 seconds to mill those 4 slots there. Exciting. Exit out of this so we can open the door. Let's give it a little puff there. Okay, I have not measured any of them yet, but we've got our little Talon grips here. I'm just going to do the test fit in them. That is beautiful. It has the same feel as in our test piece. I mean, just barely tries to catch it to hold it up, but you can see you can move it freely. Which is what you want when you want to reposition these guys. Yep, same fit. That is amazing. Wonderful. Really happy with that. And then we can try something else here too while we're at it. Let's go ahead and this looks like it's much wider than it needs to be for our stock, but we'll give you our first peek at what we're going to be using in this position. I have a piece of our material. It actually just arrived this morning. Just got it out of the box. We're going to be holding it like this. So this gap right here represents, you know, this gap here once we tighten the jaws up, and it'll clamp down on it there as well. All right, looking good. I'm happy. Starting to build up a little more confidence with our CNC stuff. Everything is, Kevin was right. He says once you learn to trust it, those tools are going to do what you told them to do. All right, so next up is going to be our second part of the operation, which is going to be spotting all the holes, drilling all the holes, chamfering all the holes, and then coming back with our tap. So we'll load that up and go ahead and get started on that one now. All right, we're just going to load the program and run. I'm not going to do an air check on it. I know that it worked over here, and so these slots are in the right place, so the drill should be in the right spot too. Let's just go with it. Turn that coolant off. All right, that comes down to our clearance plane, and then we'll just do the first one nice and slow and make sure it's good. All right, that looks good. So, coolant on, wrap it up to 100%, and here comes our feed. It's a new feature that they built into the new Inspire controller. You have a feed control knob and a rapid control, which I'm getting used to. So, you know, one just controls just the rapid movement, and then one just controls your feed movements there. So just a little getting used to, but I think I'm already getting the hang of it now. So our spot, I've got that set to go 30 thou deep. And it looks like it's working well. Now for our drill bit. All right, same thing. Let me just bring it down slow and watch it. There it is, there's our clearance plane. We're cutting. I'm going to put some coolant on it. Now will it drill it as well as it did the mild steel? I have all the feeds and speeds adjusted for high carbon steel, I believe is what the selection is. Well, so far so good. It's our first two holes. So it is going to take a little while to get through this. And I have no way to reach in there and turn the camera off. So we're just going to let it run through there, okay? We are on our last hole to drill. So I don't know if my battery is going to make it through this entire cycle. It might, but if it shuts off, it is what it is. The next two segments should go much faster than just the drilling here. But everything is working well. We're going to be going back to our chamfer tool. Let's slow this down a little bit. Yep, that looks good. Everything back to 100%. I believe I mentioned this earlier, but I'll repeat it again. I just don't trust the tool going down far enough to cut the spot and the chamfer at the same time. I feel like it might break that tip off, so that's why I'm coming back with a separate chamfering operation here. All right, there's our chamfers done. Now on to our tapping. See how we're gonna go. So far, so good. All right, hopefully it's gonna make through every hole there. If I remember correctly, just off the top of my head, I think it was around 76 holes total. Yep, doing just like it should. All right. Here's a little better look at our Talon grips that we're going to be bolting on there. Well, I'm real happy with the way the machining turned out. Everything is right on size, right on spec, just like we wanted. And the Milltronics did a great job at this. It looks good. I'm gonna go ahead and get some more of the Talon grips out of the package, and I'm gonna get some of these bolted on here. I'm probably gonna go ahead and just put 4 per slot there, so we've got a total of 8 grips per part, and we'll get those bolted down there. I gotta loosen these up, take these spacers out of there, and we'll do that and go ahead and get a couple pieces of aluminum clamped in there just so we can see what it's going to look like finished up with our actual work pieces. Here's a better look at our Talon grips installed. 4 per slot, 8 grips per part. All right, I wanted to go ahead and clean everything well before we started, so giving that one more wipe, and we'll get our jaw snapped back into place. Oh, there it is. Okay, got a couple of our work pieces here. I'll end up putting a stop in here, but for demonstration purposes, this is what it's going to look like. We'll make sure that it clamps in well. So there's one. And there's just number 2. Get our vise handle. It's going to tighten up the rear jaw first, and then the front jaw is going to tighten up. And that is working. That is working good. It sure is low on the workpiece there, but I mean these things are designed to do exactly what we're doing there. The guys at Tico and Mitee-Bite have this figured out. So these particular Talon grips, what's cool about them is that they only stick up out of your jaw a 1/16 of an inch. So you're really only, you have a 1/16 plus a little bit of clearance there of a hat left over that you have to machine off, so it kind of helps save some of the material there. And I want to read, I believe, the torque value that they give for tightening aluminum. Typical is going to be 30 foot-pounds when using 2 grippers per jaw. If using our large 8-inch jaws, and vise, torque to 40 to 45 foot-pounds. Be sure the grips penetrate the material at least 10 to 15 thousandths. More penetration is desired for softer materials such as brass, aluminum, and mild steel. So I think this is going to be one of those deals where we're just going to have to kind of play with it and get a feel for it and make sure it's there. But that feels nice and tight, and I am happy with it. Well, what a relief to finally see that ready to go. All right, this is looking good. Up next, I want to go ahead and get our other Toolex vise mounted back on the machine, get it trammed in good where it needs to be, and then we will go ahead and get that pair of jaws machined. And it's going to go much quicker than what this is right here, because we basically just have 4 channels to mill in there, which is going to be for our Op 2.